Today we're going to go through how to do some mass stoichiometric problems. And the first example, we are going to have to read what is given and try and figure out our balanced equation. I am going to use a method that requires 4 steps to solve these mass problems. There is other methods of how to solve stoichiometric problems on the internet that you can certainly explore as well. But these are the methods that I'm going to use to help you solve these problems. So you will need a periodic table on hand as well as a calculator. So in this first scenario, what they're asking you to do is to produce iron from iron 3 oxide, also known as iron ore, with carbon monoxide. Carbon dioxide is also produced. They ask you what mass of iron can be formed from 425 grams of iron ore. Seems a little bit wordy at first, but if we can break it down into reactants and products, then we are good to go. So it's saying that iron can be produced. So we know that that will be on the right side of our yield sign of our arrow. And so I will write down iron. It's saying that it's being produced from iron 3 oxide. The formula for iron 3 oxide is Fe2O3. And I know that I'm to pick a valence of 3 for iron. Oxygen is a -2. When I crisscross, that is my formula. And they're saying that it is reacting with carbon monoxide. Carbon dioxide is also produced. And it looks like we have our reactants and our products. The next thing that we want to do is make sure that this equation is balanced. So upon inspection, I take a look, I'm going to need 3 carbon monoxides, I'm going to need 2 irons, and 3 carbon dioxides. So if I take a look, 2 iron, 3 oxygens, and I've got 3 oxygens here, which gives me a total of 6 oxygens, 3 carbons, and we are good to go. The next thing that I like to do is identify what's given and what is required. So they're asking me what mass of iron can be formed. So that is the unknown that I am solving for. What mass of this can be formed when I'm given 425 grams of iron ore, also known as iron 3 oxide. So I'm given this quantity. These are the 2 substances that we are going to be working with. Okay? The next thing that you want to do is you want to make sure that the mass that is given is converted into moles. That is step 2. So what we're going to do is we're going to figure out how many moles, 425 grams of iron 3 oxide we have. So we know that moles is equal to mass over molar mass. We're going to take the mass that is given and we're going to divide it by the molar mass of iron 3 oxide, which I've already figured out from my periodic table. I've already done this ahead of time, is 159.69 grams per mole. What I will do is I will plug that in on my calculator and I get this answer here of 2.661406.475. I don't really want to do any sort of rounding at this point in time. So if I can leave that in my calculator, then that would be great. So I've got that written down. The next thing that I want to do is I want to go on to step 3 and I want to set up a mole ratio between the 2 items that I'm working with. So the ratio of iron 3 oxide to iron, according to the balanced equation, is a 1:2 ratio. I know that when I have 425 grams of iron 3 oxide, this is how many moles I actually have. So because I'm keeping that on the top as my numerator, I'm going to write out that value on the top. So I want to know how many moles of iron would I be able to produce in that scenario. I do a little bit of cross multiplying right now to solve for X. So how many moles of iron? That's what X is representing. So I haven't cleared this out of my calculator because as you see, I'm going to be multiplying this by 2, and then I'm going to divide by 1. So my x in this case will be just 2 times that value. So I get 5.3228125, and that represents moles of iron. Now, intuitively, I know that I would just multiply this by 2 because for every one of these, you have 2 of these. So it's a 1-to-2 ratio. It doubles. Now, what you're going to do is you're going to convert your mole value for iron back into mass. So what mass would that be equivalent to? What we do to figure out my mass of iron, I have to rearrange that mole triangle, and I know that moles times molar mass gives me my mass. So I have this mole value written up here, 5.3228125. And it's important to not round early on, because if you do, then your answer is not going to be as accurate as it should be. The molar mass of iron is 55.845 grams per mole. And we notice that my moles cancel out and we are left with grams. When I plug that into my calculator, I'm going to multiply times 55.845, and I get this answer. Now, how many significant digits am I going to round to? Am I going to keep all of those? No, I'm certainly not. I go back to the original question and I take a look and I notice that the original mass that was given is 3 significant digits. So I will report my final answer to 3 significant digits, which will just be 297 grams. That's as accurate as I can be. And there is my final answer. What I'd like you to do is box your final answer or highlight your final answer moving forward when you do various worksheets for me.